Hello, my name is Seon. I'm here to present you my topic, Euler Characteristic. First, let's talk about what is Euler Characteristic. Euler Characteristic is a topological invariant, a number that describes a topological space's shape or structure regardless of the way it is bent, or more commonly shown as the following equation. Chi, which is common symbol for Euler characteristic, equals vertices minus edges plus the faces. Now, let's see an example. Here we have a cube. The cube has 8 vertices, 12 edges, and 6 faces. By Euler characteristic equation, it equals to 2. This value is common to all convex polygons, and it is called Euler's polygon formula. Now, how do we calculate Euler's characteristic for a smooth surface like a sphere, which does not have defined vertices or edges? We use subdivisions. It is basically a wiring, which we envelop the surface that we want to calculate Euler's characteristic number. In this example, we use the previous cube as our subdivision wiring that envelopes the sphere. Since the vertices, edges, and faces value is shared with the cube, we have Euler characteristic value of 2. The sphere can use different wirings, like say quadrahedron or simple two lines, but Euler characteristic value will always be 2. Now let's see the deformation property of the Euler characteristic. Euler characteristic has a property that for any closed object, Euler's number is preserved even after the object has been morphed or deformed into a different shape. For example, in our animation, it shows a sphere which has an Euler characteristic of 2 transformed into a cube, quadrahedron, octagon, and back to a sphere. Notice all these objects have same Euler characteristic of 2. Now, if the object is connected and closed, there is a theorem called classification theorem which states we can classify an object into 3 categories. First, objects that can deform into a sphere, which has Euler characteristic of 2. Second, objects that can deform into a connected sum of G numbered of torus, which has Euler characteristic of 2 minus 2G. Third, objects related to connected sum of K numbered real projective planes, which have Euler characteristic of 2 minus K. Here's some representations of each categories. This example shows our group of objects deforming into a sphere. This one shows a group of objects deforming into a torus group, which represents our 2 minus 2G. The last example shows a tetrahemihexahedron, which is basically the polygon representation of a real projective plane. Viewed as the wiring of subdivision of a Roman surface, which is similar to real projective plane. As shown in the representation, Euler characteristic of this object equals 1. And that's it. Thank you for everything and leave a like and subscribe for more videos. Bye!